Hey guys, in this video we're going to be solving this trigonometric equation. So the way you would start solving this one is by making a substitution, because you can see it's got two cos terms but one of them is squared. So why not let u equal cos x? The reason why we do this is now it's going to turn into a quadratic pretty much. So you have 2u squared minus u equals 0. So you can divide both sides by u, or you can factor it out like this. So you have 2u minus 1 equals 0. So now you've got u equals 0, or you've got 2u minus 1 equals 0. The reason why we have this statement is because in order for this to be true, this statement here, u needs to be 0, or this needs to be 0. That's the only way it's possible. So u, we said, was cos x. So we have cos x equals 0. And we have 2 cos x equals, oh whoops, forgot the minus 1. Minus 1 gives me 0. So this solution here is going to be every x-intercept of cos. So if we take a look at our standard cos curve, it starts right here, goes and it looks like this. That's a beastly cos curve right there. This here is the point pi on 2. This here is 3 pi on 2. And this point here is pi. So the solutions for this is whenever cos x is 0. So that's a solution, and it goes on forever. Okay, so pretty much any multiple of pi on 2. So the general solution for this will be like pi on 2, 3 pi on 2, etc., and the negative ones as well. So a general way to express this is going n pi on 2, where n is a discrete integer. Okay. So if you put in n equals 1, it'll give you that solution. N equals, it'll be every odd term, so it'll be n plus 1, sorry. So n plus 1. So if you put in n equals 2, it'll give you that one, etc., etc. Okay. So the first answer will be x is equal to n plus 1 pi on 2, where n belongs to any discrete integer. Okay. Now this one is a bit more interesting. So let's just take this one and move it over here. Okay, so we have more room to write. So this one, we can still solve to get cos x by itself. So if I rearrange this, I'm going to have cos x is equal to a half. So what's interesting about this is what I'm looking for is the intersection between the line y equals a half. So if I go to the side a bit, so finish my cos curve. So if I'm looking for, this is 1, so I'm looking for the intersection between y equals a half, so they're here and here. Okay. Now the way we can work this out is using some special triangles. So we have two particular triangles. We have our 60 degrees, 30 degree right angle triangle, where this side is root 3 and this side is 1 and this is 2. Cos is adjacent over hypotenuse. So if this is the adjacent side and this is the hypotenuse, our angle must be 60 degrees. So that means cos inverse of a half, 60 degrees in radians, will be pi on 3. So that'll be pi on 3. So that means our first solution is pi on 3. So this distance here will be pi on 3. Now the cool thing about cos curves and other curves is because they're symmetrical. So that distance there is going to be the same as this distance here. So our two solutions will be, well, pi on 3 and then 2 pi minus pi on 3. 2 pi can be represented as 6 pi on 3 minus this. So that's 5 pi on 3. Okay. Yeah, and if you wanted more solutions, you'd have to keep graphing, but that's how you solve that particular equation. Yep, that's it. Hope you enjoyed this quick little video, and like and subscribe.